So when you're famous, you'll have super fans and crazy fans, but I'm not famous. I just have little fans. And today I want to talk about them. So welcome to the Renaissance Builder. So welcome back to the channel, everybody. Let me explain how this became by a quick story time. So you guys remember my buddy Josh.
What's up, YouTubes?
Well, he printed me up these here fan shrouds that I got off of another YouTuber's video, and I will tag that up here. Tag that video because he's the one that figured out all these 3D printing stuff, and Josh happens to have a 3D printer, so he printed me up these fan shrouds. The whole point of these fan shrouds is to turn a computer case fan, which are normally 120 millimeters, into basically desktop fans, and I thought, well, that looks unique, I'm going to try it. So I had him print me up, and he did a good job of printing me up one of those things, and then I got myself a high airflow 120 millimeter Nactua case fan. What I thought was going to be the best fan for this application. No back pressure, just blowing a bunch of air. But I installed the thing, and I was like, very disappointed. So I thought, well, you know what? I already had a high pressure radiator fan. And so I thought, well, I'm going to put that on there and see how that does. And it did better. And I thought, well, that's not supposed to be right. So what I did is I looked up on Nactua's site. Nactua gives this little chart. Now I'll post it on the screen right now. You can see it? Can you see it? Yeah, you can see it. So that chart describes 3 different fans and their relationship of airflow to pressure. And in this situation, we have 0 pressure, so the SF12, I think it is. Yeah, so well, the S12A is supposed to be a high airflow at low pressure fan. But when I put the what is it, the F12 in, I felt like it performed better. Now, I guess to describe, if you're looking at the chart, if you go back and look at the charts, I'll post it again. And it describes 3 different fans. And the point of those 3 different fans is, one is supposed to be just a simple case fan to move a lot of airflow without much pressure. One is supposed to be a fan that mounts to a radiator, so it actually has some back pressure to it, some pressure that it has to overcome. So that's the point of that fan. And then they make another fan, which is the NF-A12 by 25, which is supposed to be their high-end, best of both worlds super fan. Yeah, they got a super fan. And it is a great fan, but I don't really think it performs quite the way they say it performs. So I said, well, let's test it. So with that in mind, I went ahead and got together all the materials and implements that I'm going to need to test these fans, and that's what we're going to do. So what I've done is I took one of these here air shrouds. I'm going to call it an air shroud because that's really what it is. Well, fan shroud, I guess. So we'll call it a fan shroud. So I took one of these here fan shrouds and I put a tap off the side to read pressure. So I can read the actual pressure that's going on in here that's right in front of the fan. And then I have a vane anemometer to read the actual airflow. These are 2 measurements that are dictated on that chart that should tell what each one of these fans is doing. Well, we are going to measure it directly and then see if that chart actually holds true, because I don't think so, and I thought it was worth a try. So with that being said, this shouldn't take very long to set up. Let's set this up, and I guess I'll do, I don't want this video to take too long, so I guess I'll do a quick rundown. We'll show it testing, do a quick rundown, and then I'll create a chart, I guess, to see which one actually did better. So let's get started. So I have my makeshift testing bench set up here. This is very unscientific. In order for this thing to be like proper I would need a uniform surface in here so that I could actually calculate the surface area, the face surface area of that volume, but I don't have that, so this is what I used. I have a cheat. I do have a cheaty way that I'm going to figure this out, but it kind of rides on an assumption. So like I said, this is very unscientific. If you need better scientific evidence, well then I guess you'll just have to stick with Nactua. This is just for curiosity's sake. But here's what I got going on, right? So I have the fan shroud to collect the air coming off the fan. I am using what's taped up on the surface here is called a vane anemometer. That's going to measure the actual airflow coming off of the fan. And then you can see on this side, there's a pressure tap. So that will allow me to read the pressure and the airflow coming off of this fan. And that information gets reported back to my phone here that I will use to record the data. To power the fan, I have an old benchtop power supply. It's not the most accurate thing in the world, but it should provide a consistent 12 volts to all the fans so that is even. And that's being monitored by this here multimeter. So with that, I've got all 3 fans. And I took the liberty of creating a whiteboard where I'm going to keep track of the measurements on. And that is airflow and pressure for each. All right, now we're going to start with, and I'm probably going to fast forward through this so the video is not too long, but we're going to start with the I believe it's the SF12. I have it on there so I can't see the name. The S12, NF-S12. We're going to start with that. Testing is done. I got an answer. And it may not be the answer you expect. Or you're looking at me like, this guy doesn't know what he's talking about. And maybe you're right. After all, this is just a curiosity. So here's what we got. The A12, we normalized our readings according to what the A12 should have been doing. And that has to do with, all that has to do with is the cubic meters per hour. In other words, in order to know the cubic meters per hour, I need to know how fast the air is moving and how much of the air there is. And you figure that out by the volume of the area it's moving through. So for example, if I have if I have 1 cubic foot of space here and I'm moving 1 feet per minute, then I would have 1 cubic foot per minute kind of thing. In this case, it's metric, and I don't know metric because I work in freedom units. But regardless, our testing has revealed one specific thing for sure. When we normalize our readings according to what the A12 should be doing at its given pressure, the pressure we know, that's not a lie, it's not a calculation, it's not a guess. So we know that's the pressure. The air volume that it should be doing according to that pressure, we normalized it for that on the A12. And from there, we read the other units, given that as our standard. And here's what I found. Both the F12 and the A12 vastly outperformed Nactua's stated figures. In other words, both of them are doing over 100 cubic meters per hour when Nactua says at this pressure they should be doing close to 20 and 40, between 20 and 40 cubic meters per hour. So they vastly outperformed in that regard. However, the clear winner of this test of how much air, given everything else this is the same, the F12 definitely moves more air than any of the rest of them. However, the A12 moves nearly as much air with only 10 cubic meters less, not even. The A12 moves nearly as much air, but significantly quieter, as in you can barely hear it run, whilst it's still moving the same amount of air as, or almost the same amount of air as the F12, and the F12 you can certainly hear it run. So that's something to think about. If noise is a concern for you, the A12 is definitely the clear winner. But if all you care about is sheer performance, in this case I'm going to have to go with the F12. So Nactua be damned. If you guys want the best 120 millimeter fan for moving air, I'm going to tell you to go with the NF F12. Because that appears to be better. Just, that's how it works. So, with that, that wraps up this test. And it actually clarifies a lot of things for me. I wasn't losing my mind when I thought, well, hey, this thing's actually moving more air when it's not supposed to be. Go figure. Anyhow, I'm not crazy. Well, I am crazy, but not with this one. Thank you very much, everybody, for watching. I really appreciate it. If you don't mind, go ahead and hit a thumbs up on the video. It would help. Leave a comment. If you think that if you want to argue whether this is accurate or not, I already know. It's not technically accurate, but it did get the job done. So if you like the video, by all means, throw that thumbs up, and make sure you hit the subscribe. Videos are coming out slow right now, but a lot of content, a lot of things are happening in life, so the content should be increasing dramatically shortly. So make sure you hit the subscribe button. So hit the bell, hit the subscribe and bell icon, throw a thumbs up. Really appreciate you guys watching till now. Thank you very much. You guys have a good night.
Bye-bye.
You know why I need this fan so much? Because I'm hot.